Alrighty, so we found a logistic regression model that performs pretty well, but we went and showed that to our boss, and then she said we had to find a whole bunch of things like hyperparameter tuning, feature importance, confusion matrix, cross-validation, and these things could sound made up to someone who's not a budding data scientist or machine learning engineer like yourself. But being the budding machine learning engineer and data scientist that you are, you know that data scientists make up words all the time. And the good thing is that these aren't made up. These are things that we can actually find. So now we've got a baseline model, and we know a model's first predictions aren't always what we should base our next steps off. What should we do? If we remind ourselves of the classification metrics and regression metrics, we're not worried about regression, right? Because we're working on a classification problem. We've used the default accuracy. And then there's precision, there's recall, and there's F1, which are all part of the things that the boss asked us. And we got a confusion matrix. Okay, we should probably make one of them since we're working on a classification problem. Then we got a classification report, which has a bunch of information here like precision, recall, F1 score, support, accuracy, macro, average. Far out. And then we've got hyperparameter tuning. We've covered before, but we've got a lot of steps. So first, we should put down what we're going to tackle. Let's look at the following. Because we're a part of the experimental phase, that's what we're going to be working towards. We're going to be taking our models that we've got, these are our baseline models here, and we're going to be experimenting with them further, seeing if we can improve them and seeing, does logistic regression perform best on accuracy? Or could a tuned or hyperparameter tuned version of a random forest beat it out? Or maybe KNN could improve. Who knows? Let's write down a list. Let's look at the following. Hyperparameter tuning, feature importance, confusion matrix, cross-validation, precision, recall, F1 score, classification report, ROC curve, area under the curve. So as we saw in the scikit-learn section, these are some of the things that you should pay attention to when you're working on a classification model. These two here are actually part of almost any machine learning model that you'll be working on, but these are specific to classification. We've seen the difference between regression and classification metrics, but since we're focusing on the classification problem, whether or not someone has heart disease based on their health parameters, we're going to be focused on looking at these. So let's jump into it. So the first things first, why don't we try hyperparameter tuning and cross-validation? And remember, what's hyperparameter tuning? Well, to cook your favorite dish, you know that to set the oven to 180 degrees and turn the grill on. But when your roommate cooks their favorite dish, they set the oven to 200 degrees and use the fan force mode. Same oven, different settings, different outcomes. This is the same for machine learning algorithms. You can use the same algorithms, but change the settings, aka hyperparameters, and get different results. But just like turning up the oven too high, if you do that for machine learning algorithms, you tweak the settings too much, you can change the settings and it works well, or so well that it overfits. So we're really here, what we're doing to do is look for the Goldilocks model, one which does well in our data set, but also performs well on unseen examples. Should we tune a k-neighbors classifier? Yeah, we might do that. Even though we've said goodbye to the KNN classifier, we might just see how would you tune it. And if you're wondering where I would start if I was trying to approach this, this is what I'd start with. How to tune a k-neighbors classifier model. We go here, in-depth parameter tuning for KNN, model selection, tuning and evaluation in k-nearest neighbors. So if we were to read through these, we would probably find some information that we're going to cover here. So let's start it out. Let's make a little heading here. We'll go here, hyper parameter tuning, let's tune KNN. Let's go a list of training scores, an empty list. So train scores, and then a list of test scores, empty list. Because what we want to do is compare different versions of the same model, so model with different settings, and compare their scores on the two different data sets. Looking up what we looked up before, if we were to read into these, again, you can do this with almost any machine learning model, or basically, yeah, any machine learning model. This is a part of the research. This is a part of the experimentation step of many machine learning problems, is searching up things like this, then reading what you can find and bringing it back to a scenario like what we're doing here. But let's just pretend we've gone through that. So we're going to create a list of different values for n neighbors. Now, why n neighbors? Because, as I said before, when we did our reading, we found that if we go sklearn knn, kneighbors classifier, we see that n neighbors is one of the parameters. And we could see this by reading through the documentation of scikit-learn as well. And so the number of neighbors used by default for kneighbors queries. In our research on how to tune a KNN model, we found that we can adjust the number of neighbors. And if you want to find out more about this, you can check out the documentation. You can read it up here. So that's what we're going to do. We're going to create a list of different values. So the default here is 5. So maybe what we might do is try different values from 1 to 20 or something like that. So let's see here, neighbors equals range 1 to 21. Wonderful. And then we're going to set up KNN instance. So we'll go maybe KNN equals, what is it? We know this. Kneighbors classifier. Beautiful. And then we might go loop through. We need to loop through different n neighbors, which is our list that we made here. For I in neighbors, I'm thinking out loud here, we'll go knn.set params. Remember, you can adjust the parameters of a machine learning model in scikit-learn using .set params, equals I, because I is going to loop through this range here. Wonderful. And then we're going to fit the algorithm. What we're trying to do here is improve on this baseline score. So this is with the default of 5. And so we're going to try 20 different versions, 1 to 20, to see if it's any better. Oh, that didn't do anything. I accidentally hit Shift Enter. I'm trigger happy, you know. My fingers are they just default to Shift and Enter whenever they want. Now we want to update training scores list. So we're going to go training. We want train scores up here. Train scores.append. Now we want our KNN instance.score on xtrain, ytrain. Wonderful. And then we want to update the test scores list. And we'll do that test scores.append knn.score. And you can probably guess that this is going to be on the test set. Beautiful. Bonus points if you did. Now, what this is going to do is just going to loop through this range of 1 to 20. And then it's going to create 20 different KNN models and append their scores to lists. So let's check out those lists. Train scores, Shift Enter, wonderful. And then go test scores. Yep, typo. Okay. Now we've got 20 different scores or so, but these are probably best visualized. Let's see how we would do that. Let's go plt.plot. We'll go neighbors, and we'll go train scores, and then we'll go label equals train score, of course, yes. PLT will add another plot, neighbors, test scores, label equals test score, wonderful. And we want to go PLT, actually let's just see what this looks like, X label, we'll go number of neighbors, because that's what's on the X. I'm spelling neighbors the Australian way here with the U there. Or maybe it's not Australian, maybe it's just a different version. But neighbors in scikit-learn is spelled with no U. So this is the X, and then plt.y label is going to be the scores. So this is X, Y. So this is going to be model score. And then we want plt.legend. And we'll see what comes up. Actually, we might, a little tidbit here, max F, so maximum KNN score on the test data. We're going to go max test scores, it's going to be accuracy, so we want times 100.2F, close parentheses, and then close string. That should work. Wonderful. Okay, so we can see here that we're really paying attention to this test score here. So we get the highest value here is around about 11 for k nearest neighbors. So if we look at the graph, actually let's adjust these xticks so we can see where it actually is. xticks.np arrange 1 to 21 space of 1. So what this is going to do is just bring out a list of range of 1 to 21 of space 1, which is the exact same as what we're using here. So neighbors equals range 1 to 21. So let's do that. And yes, our assumption before we adjusted the xticks, which is these just little labels down here, was that a KNN, or an N neighbors value of 11, yields the best score on our test data set. So if we come up here, the default we remember is 5. So we've just done a little bit of hyperparameter tuning, and we were able to improve our KNN classifier's results on the test data set by changing it from the default 5 and N neighbors parameter. So we're doing hyperparameter tuning here. Change that to 11, and we get 75.41 versus our initial result, which is back up here, of 68%. Well, even then, even after improving it to 75 or whatever it was, it's still far below our logistic regression and random forest. So I think this has put the nail in the coffin for our KNN model, is that because even with a hyperparameter tuning, it still hasn't reached the scores that we got with logistic regression or random forest. And so because of this, we're going to discard KNN for now. This is part of our experiment. A big part of experimenting in machine learning, step 6, is going through different machine learning models and figuring out which work and which don't. So what we're trying to do here is, as quickly as possible, work through different little experiments like what we've just done tuning KNN and seeing which model performs best on our data. So what we might try and do is we've tuned KNN by hand. Like we wrote out this little for loop here. That was a bit tedious, right? So if you had to do that for every single machine learning model, you might run into some problems. It was okay here because we had one parameter tuned, but if you had more parameters, writing these for loops is going to be very inefficient. So what we might do next is see how we can tune logistic regression and random forest classifier using randomized search, CV, which stands for cross-validation. So instead of us having to manually try tuning different hyperparameters by hand, randomized search CV, which we've seen in the scikit-learn section, it's going to try a number of different combinations of hyperparameters for us and evaluate which ones are the best and then save them for us. So that's what we're going to have a look at that in the next video.